Imagine waking before dawn with a deep ache behind your last molar, a pressure hidden beneath the gum where your tongue cannot quite reach. At first you ignore it, but chewing becomes awkward. Sleep breaks into short pieces, and the dull pressure begins following every movement of your jaw. Soon, you are beneath a bright dental lamp, staring at a grey image, while someone points toward the very back of your crowded mouth. The diagnosis sounds simple. A wisdom tooth is trying to emerge, but the path ahead inside your jaw may be narrow, blocked, tilted, or already occupied. That leaves an obvious question. Why would the human body grow a tooth that can become trapped, inflamed, painful, or harmful to its neighbor? Wisdom teeth are not mysterious extras. They are third molars, the final grinding teeth positioned behind the rest of the permanent dental row today. Unlike most permanent teeth, they complete their journey late, often when the other teeth have already claimed nearly every available place in the jaw. By the time this final molar approaches the surface, its doorway may be angled, partly sealed by bone, or crowded by the tooth ahead. Yet the tooth is not choosing badly. It is following a developmental program inherited through countless generations of humans who lived before modern dentistry. So the mystery is larger than one painful appointment. It asks why bodies carry ancient structures into environments where those structures may no longer fit. A popular answer says wisdom teeth are useless leftovers, an evolutionary mistake that should have disappeared long ago. But evolution does not edit like an engineer. Some third molars emerge normally and help with chewing. Some never form. Others remain hidden, shift position, or create trouble only much later without warning. This is not the story of one universally defective tooth. It is a story of timing, variation, inherited anatomy, growth, and limited space inside us. To understand that missing space, we must leave the clean dental room and return to mouths shaped by colder nights, tougher food, and harder lives. Back before X-rays, blenders, forks, and orthodontics, teeth were not simply part of a smile. They were survival tools, and every molar carried history. Picture a prehistoric camp beside a cold grassland, where a small group gathers near the fire, while wind moves through the darkness beyond them. Their food does not arrive in identical packages. It changes with season, landscape, skill, luck, and whatever animals or plants can be found nearby. Some meals are cooked, others are dried, crushed, sliced, scraped, pounded, or eaten with tiny particles of grit that slowly mark the enamel surface. There was never one universal prehistoric diet. Humans in forests, plains, mountains, and coasts placed very different demands upon their teeth every single day. Yet in many ancient lives, eating required more physical processing than opening a wrapper. Hands, stone tools, fire, and teeth all shared the work. Once food entered the mouth, molars crushed and ground what remained, while teeth sometimes carried wear from practical tasks beyond ordinary chewing each day. Studies of hunter-gatherer teeth show that wear patterns can reflect differences in diet, environment, and even the ways teeth were used as everyday tools. Neanderthal molars preserve microscopic traces that vary with habitat and food, reminding us that ancient chewing was neither simple nor identical everywhere in the past. In a mouth exposed to heavy wear, a functioning third molar could become useful chewing surface instead of an obviously useless intruder at the back. But this does not mean every ancient human needed 4 wisdom teeth or possessed a huge jaw with perfectly aligned teeth throughout an entire lifetime. Ancient people experienced broken teeth, cavities, infection, heavy wear, and developmental variation. Nature never promised dental perfection for every human in any age or landscape. The real difference is not strong ancient humans versus weak modern humans, but bodies developing under different combinations of genes, food, forces, and environment. The third molar belonged to a complete chewing system, shaped by facial growth, tooth wear, muscle activity, and the demands of everyday prehistoric survival. As that system changed across generations, the last molar did not instantly disappear. Evolution preserves workable variation far more often than perfectly engineered solutions. To understand how an ordinary grinding tooth became a crowded late arrival, we must follow the slow transformation of the entire human jaw itself. The human face did not shrink the night someone first cooked dinner. Evolutionary change rarely begins with one invention, one meal, or one dramatic turning point. Instead, imagine thousands of generations moving through overlapping changes: new tools, new foods, new climates, migration, cooking, agriculture, and different patterns of daily effort. Cutting, pounding, grinding, and heating food can reduce the mechanical work required inside the mouth, long before the first bite is finally chewed completely. But connecting softer food directly to every wisdom tooth problem demands caution, because jaws grow through a complex interaction of genes, muscles, nutrition, health, and timing. Our jaws are inherited, yet development also responds to forces created by chewing muscles, facial growth, posture, hormones, illness, and the texture of childhood diets. Animal studies show that softer food can alter craniofacial growth, while human research links facial form with the likelihood of third molar eruption or impaction. Still, an animal experiment cannot perfectly predict a human mouth, and a statistical association cannot prove one simple cause for every crowded jaw either. Human populations differ in ancestry, tooth size, facial proportions, health, childhood environment, and growth patterns, so the same diet may not produce the same result. There are really two stories unfolding together: one evolutionary, changing populations across generations, and one developmental, shaping a single person as the jaw grows. These stories can interact, but they are not identical. A response during childhood does not automatically become a genetic evolutionary change across an entire population. Even saying the human jaw became smaller hides complexity, because upper and lower jaws change differently, while tooth size does not always shrink at the same pace. One person may inherit relatively large teeth, limited posterior space, a late growth schedule, or an eruption angle that leaves the third molar poorly positioned. Another person raised in a similar environment may develop enough room, allowing the same final molar to emerge normally and function without serious trouble. So cooking did not simply make wisdom teeth useless. Food processing was likely one influence within a much larger transformation of human biology and behavior. That transformation created the possibility of mismatch, an ancient dental sequence finishing inside a jaw whose final architecture may no longer accommodate every tooth comfortably. Deep behind the second molar, a wisdom tooth begins forming years before anyone feels pressure, pain, or the slightest sign of its arrival. It develops near the rising back portion of the lower jaw, where space, bone shape, and tooth direction can keep changing during growth. The tooth does not rise like an elevator. It rotates, shifts, and follows a path shaped by neighboring teeth, surrounding bone, and continued facial growth. For some people, everything aligns. The tooth reaches the chewing surface, can be cleaned normally, and joins the other molars without causing serious trouble. For others, the path closes. The tooth may remain beneath bone, stay partly covered by gum, or lean forward against the second molar. That condition is called impaction. Normal eruption is prevented by surrounding structures, or by an unfavorable relationship between tooth position and available space. Limited room matters, but it is not the only cause. Wisdom tooth impaction develops through several interacting anatomical, developmental, genetic, and environmental influences. Jaw dimensions, tooth angle, local bone shape, eruption timing, facial proportions, and inherited growth patterns can all influence where the final molar ends. Even an unerupted wisdom tooth is not permanently frozen. Its angle and position may continue changing after the age when growth seems nearly finished. Some retained third molars remain quiet for decades. Others become associated with gum disease, decay, or damage affecting the neighboring second molar. That is why wisdom tooth does not equal useless tooth. It may be functional, absent, hidden, changing, harmless, or connected with disease. Evolutionary mismatch describes the wider pattern, but it cannot diagnose one person or predict exactly what a particular wisdom tooth will eventually do. Your mouth is not an average mouth. It is one unique combination of skeletal growth, tooth development, ancestry, environment, health, and chance. Evolution did not forget to measure the jaw before sending the final molar. Evolution has no blueprint inspector, intention, or quality control department. It passed forward a variable developmental system, and sometimes the last tooth reaches a space that the rest of the face has already taken. Now remove the dental chair, the X-ray, modern pain relief, sterile instruments, and every clear explanation for what is happening beneath the swollen gum. You are beside a prehistoric fire, and the pressure behind your last molar has become a slow pulse that follows every bite, swallow, and attempt to sleep. Outside the shelter, life continues without sympathy. Firewood must be gathered, water carried, food processed, and the group may need to move before weather changes. A painful tooth need not become dramatic to affect survival. It can slow chewing, interrupt sleep, weaken attention, and turn ordinary work into exhausting effort. In a cold landscape, eating less is not merely uncomfortable. Energy becomes protection, movement, warmth, healing, and the strength required to remain with the group. A person unable to chew available food may depend more heavily on companions, turning a private pain inside one jaw into a problem for everyone. But prehistoric people were not helpless caricatures. They possessed observation, plant knowledge, practical tools, memory, experimentation, and social care passed through generations. What they lacked was the ability to see through living bone, identify the hidden tooth's angle, or predict whether swelling would remain local or worsen. Archaeological teeth preserve evidence of wear, cavities, infection, and deliberate intervention, showing that dental pain shaped human behavior long before formal dentistry existed. One upper Paleolithic tooth even preserves signs of deliberate cavity manipulation with a small stone tool, evidence of experimentation rather than modern dental practice. That discovery does not prove prehistoric dentists existed as we know them. It reveals something more basic. Persistent pain encouraged observation, risk, and invention. We should not assume every ancient toothache came from a wisdom tooth. Cavities, fractures, wear, gum disease, and other conditions could produce similar suffering. Bone may preserve an impacted molar, but gums, swelling, pain intensity, fever, and many soft tissue complications usually vanish from the archaeological record entirely. So the prehistoric scene remains uncertain. One person awake beside the embers, touching the back of the jaw, while companions sleep only a few steps away. Beyond the fire, predators remain distant silhouettes. Yet tonight, the closest threat is not outside the cave. It is hidden inside the human body. There is another version of this story. For some people, the final molar never becomes crowded, trapped, painful, or functional because it never forms at all. This is third molar agenesis, the congenital absence of one or more wisdom teeth rather than teeth lost later through extraction, damage, or disease in adulthood. It can sound as though the human body is deleting an obsolete part, and online explanations often call this evidence that humans are evolving past wisdom teeth. The reality is more interesting and less certain. Third molar agenesis varies widely among individuals and studied populations, and inherited biology clearly contributes to that variation. Twin research suggests that genetic factors influence whether third molars form, with some studies finding especially strong inherited effects in the upper jaw region. Genome-wide studies have also identified genetic regions associated with missing third molars, although tooth development depends on complex networks rather than one simple switch. The absence of wisdom teeth is also linked with differences in facial and jaw size, suggesting coordinated development instead of one tooth disappearing completely alone. But association is not destiny. A smaller face does not guarantee missing molars, and missing molars do not prove someone represents a more advanced human form. Evolution has no ladder, with wisdom tooth-free people standing at the top. Different dental patterns are variations, not ranks in a march toward biological perfection. Variation is simply the raw material on which evolutionary forces may act, but a common trait does not automatically have a clear future direction. To demonstrate ongoing directional evolution, scientists need more than observing that many people lack these teeth. They need evidence of change across generations and reproductive consequences. Modern dentistry further complicates that story. A tooth that once might have reduced health or survival can now often be monitored, treated, or safely removed. Culture changes the environment in which natural selection operates. Tools, medicine, and social care can weaken, redirect, or transform biological pressures that once mattered more. So perhaps third molar agenesis will become more common. Perhaps frequencies will remain uneven, or different populations will continue along different developmental paths for many generations. The honest answer is that we do not know the future of the human dental formula. But modern crowds already preserve several possible versions of our past. The painful wisdom tooth tempts us to imagine evolution as a careless designer, because a competent engineer would surely remove a problem that causes so much trouble. But natural selection never begins with a blank page. Every generation develops from an inherited biological system already filled with connections, compromises, and limits. Teeth, jaws, muscles, nerves, skull shape, childhood growth, and the timing of maturity cannot be edited independently like separate parts inside a digital model. A change that reduces one problem may create another, while the same trait can harm some people, help others, or remain completely neutral in life. Natural selection does not erase every feature capable of causing pain. Its effects depend on timing, frequency, severity, inheritance, environment, and reproductive consequences over generations. Wisdom tooth problems may appear late, never appear at all, or be reduced through behavior and care, creating weaker and more complicated selective pressure over time. The same body can therefore contain structures shaped under different chapters of human history, some ancient, some recently modified, all still interacting inside us today. Our upright posture gives us remarkable movement, yet it also places unusual demands on the spine, hips, knees, and the balance required for walking. Our large-brained infants bring extraordinary learning potential, but their development also creates difficult trade-offs in pregnancy, birth, dependency, and long childhood care for families. Our threat-sensitive nervous systems can protect us from danger, yet they may also react intensely inside environments far safer than the landscapes where they evolved. These comparisons do not mean every backache, difficult birth, anxious feeling, or dental problem has one simple evolutionary explanation waiting to be discovered by science. Imagine Wonder holding a glowing image of a modern jaw, while behind him, a prehistoric figure sits quietly beside a small and flickering fire.